Right now we'll have a short talk by Milos Meriak and Chiro Katutu, who will tell us how RFID can be used to reveal social contacts and give us some statistics on the little experiment that they've been doing during this very Congress. And that's hopefully going to be very interesting. Unfortunately, the third person, Aesthetics, won't be here today because he's ill, but I hope it's nevertheless going to be very, very interesting and you can enjoy the talk.
Hello everyone, I want to welcome you in our open AMD talk, where we want to tell you what our findings were with the current instance of OpenBeacon and OpenAMD. We tell you about what new friends we found, which built on top on OpenAMD. We'll show you what data we can retrieve with the current versions and what the implications are. We will give you a short introduction to the hardware so you get an idea what the capabilities are and thus what the implications are. And we will show you what the current status of our data mining efforts is and how our web APIs could look like. And yeah, unluckily, we had a lot of misluck with this project, so this is only shows at the end that people now also get ill, despite the fact that they had to work very hard to compensate other people that went missing along the project progressed. So just to say it in advance, this project was only possible because very few people worked really, really hard the last say 2 or 3 weeks and made this possible, especially people like Aesthetics, who unluckily can't attend here. He did amazing work with the data mining APIs, and unluckily we can't show you his part of the presentation, but we try to do our best. And Chiro, which is basically one of the new friends of OpenBeacon OpenAMD, is presenting a group that built very nice software on top, which shows what data is actually there from the data we retrieve. So the first time it's actually visible, not only to mathematicians and sociologists, what data is there, but really everyone can point their browsers to our website, and it's very visible what amount of data results, and therefore you have to ask yourself if you really have nothing to hide. Okay, so let's give a brief introduction to the OpenBeacon hardware. OpenBeacon exists since something like 4 years now. It started basically when we were discussing with a friend how to basically enable scientists, for example, to examine crowded situations where people get killed because panic situations emerge. And the background back then was that people regularly got killed in Saudi Arabia on the Hajj, on the yearly Hajj, because you have this huge crowded situations there. People have to fulfill waypoints there, and you have huge cities of tents. When a fire starts, people get panicking, and basically more people are killed by the resulting panic than by the actual fire. So we thought about, okay, how could it look like if you want to track a huge amount of people? Obviously, there are several existing technologies available, namely low-frequency RFID and high-frequency RFID. You probably know low-frequency well, which is basically the 100 kilohertz approach, which is used in cars still, and basically in huge sports events. 13.56 megahertz you probably know very well from your travel passes or your subway tickets. And all these existing possibilities share the problem that you have to provide a very tight net of readers around the city, for example, if you want to track people. So we try to find a novel approach where the basic design pattern was that it has to last at least a few weeks, and that it's easy to deploy. Obviously, if you have to control a huge crowd of people, you can't lay wires everywhere and stuff like that. So you need a wireless approach, and because current technologies are very low power, namely 2.4 gigahertz, and 2.4 gigahertz is available worldwide, we decided to stick to 2.4 gigahertz because we learned the more generic your system is, the more people can contribute. Therefore, we not only wanted to make this RFID tracking project possible, but we tried to create a very generic hardware platform which enables, for example, scientists to create micro-netting networks or wireless sensors and everything. So every, for example, tag, maybe few people of you bought, is, for example, able to receive and transmit data, which I'll later explain. Because in this particular instance of OpenBeacon, all your tags you currently wear started to talk to each other. Last year's version of OpenBeacon was pretty simplistic. We didn't want to take chances. So the tags were just blindly transmitting, no matter if there is a tracking infrastructure available, no matter if you're on the BCC, they were just transmitting constantly their beacon packets. Although they are encrypted, so you can't be tracked by others, only people that know the secret key we use in our firmware. But it was a very stupid protocol. The background is that it's very cheap in terms of power consumption to transmit short packets. In the case of 2 megabits, the packet transmission is surprisingly low. So the actual packet on air takes 600 microseconds. So even if a crowded situation, we have thousands of people, the likelihood of a collision is very, very low. So we thought, okay, that's easily possible to build a tracking upon this technology. And by getting rid of the back channel, which could result in freezes of the system, because if, for example, imagine 1,000 people talking to a reader and saying, hello, I'm here, and they will obviously cancel out their own transmission, and they will obviously have to repeat this transmission if there is the connection fails. Thanks. And this could result in lockup. So therefore, we took no chances, said, okay, we make a very simple version. Privacy is a top priority for us, so we wanted to make sure that whoever has access to this data, this results in well-defined conditions. So basically, we are in control what we get and what data we release afterwards. And obviously, it needs to be fail-safe, because you think about a technology, say, okay, it might work, but obviously at some point you have to spend actual money to build 1,000 of these devices and to simply try it out. So if in case of a failure, this could obviously result in a problem. So, but this year we decided to bring, with the help of Tiro, to a new length, and by introducing tags talking to each other. So additionally to the announcement of the former OpenBeacon protocol, which basically on a scheme where you have transmissions on 4 power levels, and the resulting packet loss is used to determine the actual distance to every reader. You additionally have a second channel where you have encrypted transmissions between all the tags, and here every tag can find out about other tags in its proximity. So every tag is now a sniffer and registers incoming packets, decrypts them, takes the tag ID out, and retransmits them along with the normal tracking packets to a server. So we slightly changed our format, and the results were really mind-boggling what data was made available with that. And Ciro will now explain you what they did.
Thank you. No. Can you hear me? Yeah, I guess so. Okay. So first of all, I would like to thank the organizers and the program committee of CCC for having me here, and I would like to thank the OpenAMD and Open Beacon team here at 25C3, and in particular Brita and Milos Merjak for their support and very interesting and exciting interactions. What I will talk about in the next 25-30 minutes is a project that we started building exactly on top of the Open Beacon platform at the Institute for Scientific Interchange in Torino. Most of us are actually physicists, and our interest here is not in the physics of the devices, but actually in what kind of patterns and network structure you can mine in terms of social activity when you deploy these devices inside the community in a closed environment. Very briefly, this is the outline of the next 20 minutes. I will show you how we can modify the platform developed by Milos and his team in order to detect reliably face-to-face social interactions. And then I will show you what kind of results you can get by focusing on a couple of small-scale conferences that we performed, that we studied back in Italy. And I will show at the end some very early, very preliminary results regarding the experiment, which is currently running here at 25C3. If you have any questions, feel free to interrupt me at any time. I enjoy that. Okay. So, why do we want to detect contact between people? There are many reasons. The problem is the following. Imagine that you have a room, like it happens in many places in this building, where you have groups of people interacting, talking socially with each other. Basically, what you want to do is, ideally, to mine in real time these kind of structures. Okay? Groups of people interacting socially with each other. Now, by interacting socially, you can mean many things. In the following, I will mean just a face-to-face interaction, which is usually a good proxy for a social contact. It means if you spend 10 minutes in front of each other, within 1 meter, you're probably doing something together and probably talking. And okay, so ideally, you want to mine this graph structure from the real-world data of social contact. And why do you want to do that? This may be a reason, but basically the problem is that we lack fundamental knowledge on human contact. I mean, paradoxically, we know much better how the surface of the moon looks than what are the statistical properties of the contact between people. And these statistical properties, knowing how many contacts are there, how do they last, this kind of information is crucial because to date, a lot of information is somehow riding on these contacts. So you can easily imagine that in the future we'll have peer-to-peer mobile content distribution platforms, and they will rely and they will have to be designed in order to be aware of these contact partners. There are reasons which are even more practical. When you study epidemics, when you study airborne diseases such as SARS, for example, you would like really to model a scenario in which a person in here has an airborne disease, something serious, and you ask the question, okay, at the end of the day, how many hackers are sick? How many will be dead in a week? Okay? So far, basically, there is no fundamental knowledge that would allow us to model this kind of processes. And most epidemiological models model the interaction in closed spaces as a random graph, and as I will show you, this is absolutely not the case. And so there are a lot of heterogeneity, there are a lot of features which actually make the spreading of diseases very different. Okay? So we lack this knowledge, and these are all scientific reasons, I already mentioned this. And then there is another issue that ideally, we would like to integrate in real time data from the real world, from sensors, with data from online systems. So you have seen that on the web during this conference, it was available a web client showing your ego network, the network centered on you, showing your friends, the friends of your friends, which contacts were actually active at the time. If you push this one step further, what happens is that you will be able, in the near future, to browse the same kind of information on a mobile device. And if you imagine what will happen maybe in 4 or 5 years, mobile devices will have several ways of assessing proximity and relations, and you will be able to enrich in real time the social interaction you're having with people with contextual information which depend on who they are. So there are really several reasons why you want to do that. Now, what do you need in order to be able to reliably perform contact detection? This is the process we want to effect. You need a spatial resolution of the order of 1 meter. This means that basically if you use position locative technologies, inexpensive locative technologies, as a proxy for contact, that's not good enough. The resolution you have in the visualization that you see spinning at the OpenBeacon booth has a resolution of like 5 meters, 6 meters, exactly. And of course it depends on density on the antennas, but it's not good enough to assess social contact. You cannot reliably detect face-to-face interaction within 1 meter. Then there is an issue of anisotropy. I mean, 2 people facing each other is different from 2 people facing away from each other. And if you look just at position, you're not able, of course, to resolve this. And the other thing is that you need the temporal resolution of the order of the scale over which people move around, which is like 5-10 seconds, the time it takes for a social contact to assess and break, in a sense. This is the fastest time. And of course, it needs to be unobtrusive. You need to have small devices. There were early exploration of these concepts at the MIT Media Lab, where they were using what they call sociometric badges, which are rather bulky devices. They capture a lot of information, a lot of context, the tone of the voice of the wearer, a lot of relevant information if you want to do anthropological or organizational modeling, but they are obtrusive. People are aware of them, and in principle, you can never rule out that this awareness biases the interactions. So you want something that people are aware of at some point. And of course, you want to scale. In order to scale, you need to have very cheap devices, possibly manufactured like the OpenBeacon devices from off-the-shelf hardware. And then, of course, I mean, and this is along the lines that are most interesting for people attending this kind of events, we really want this platform to be open in order for scientists, for practitioners, for people to hack it, to build stuff on it. I mean, if Milos hadn't decided to make this platform open, as a scientist, we wouldn't have been able to modify it and do science on top of it and use it in order to gain extended knowledge. So Milos already spoke about the OpenBeacon tags. Let me just repeat that the active RFID tags, they're very easy to reprogram. In the default behavior, they just scream on a given radio channel their identity. So the data collection pipeline is really simple in that case. You have tag 42, which emits a packet. In the packet, which is encrypted, there is embedded the information at which the transmitter on the device was asked to emit the packet. And then there is a collection infrastructure, and this collection infrastructure eventually encapsulates the radio packets over UDP, streams them over the local network until you get to a data analysis, storage, and collection system. So this is rather simple. I'll show you what you can do, what we did here in May at a small conference. This was with about 70 people at our premises in Torino, so it was easy for us to wire up the environment. We had basically 3 rooms. This was a cafeteria, this is a bar, and this is the conference room. And the locations, the dots mark the readers. And in this case, we used the system basically to assess co-presence in the vicinity of a station. Okay, so what you will see in the following, consists of a graph where a node is a person and 2 nodes are connected if those 2 persons have been seen by the same station during the last 10, 20 seconds, okay? So because of this, and because basically you have a very coarse kind of spatial resolution, the graph will look very clickish. You won't be able to resolve small groups of people. You will just see vicinity relationship. Here, the different readers, the antennas are laid out like this in order to provide some sort of spatial grounding. This is not spatially grounded. Here, the position in this graph is not representative or easily mapped to position in space. even though the points gravitate towards the antennas that see them most often or the strongest. So you see, this is 9:30 in the morning, and people are piling up in the conference room. And you see that basically, in this case, we completely lack resolution of what's happening in the conference room. The system basically tells us, okay, there are a lot of people who are co-present in the vicinities of these antennas, okay? And then what you see is that, this is kind of fun, during the coffee break, and you can imagine what's going to happen, of course. People migrate to the bar. A few of them are really resisting and keep talking science. Eventually they get absorbed, but it's too late, okay? So this is the kind of information that you can... This is the kind of information that you can get, but this is not good enough for science, okay? So what we wanted to do was move this platform one step further, and we have the hardware, which is very nice, we can reprogram it, and we really want to address this problem. Given this structure, how can we get this graph? And we already, basically, Milos already solved for us these problems. This is unobtrusive, it's scalable, it's low cost, it's open, okay? We had to solve 3 other problems. Anisotropy, the spatial resolution issue in assessing contact, and the temporal resolution. That's really not a big problem, actually. And so this is the basic cycle of functioning of the standard OpenBeacon firmware. You transmit, then you sleep for a long time, and the system consumes very small amount of power, and then a timer wakes it up, you transmit again, and so on. This is randomized in order to minimize the probability of in-air collisions. And what we did is modify this simple scheme into something a little more complicated, where we work over 2 radio channels. And this is what we had here at 25C3. Basically, when you transmit over a complex cycle, where in 7 times out of 8, you transmit on channel B. Channel B is used for neighborhood sensing. It's used to talk to other devices which are in your proximity. On this channel, we are transmitting at the lowest powers. We are transmitting at power 0 and power 1. And then 1 time out of 8 transmissions, we talk on the channel which addresses the infrastructure, data collection infrastructure. And we cycle over different powers, as Milos was saying, in order to be able to compute drop rates at the different readers, which are used for positioning. And then we use the strongest power, at which you really don't have a lot of spatial resolution, so it's not very useful for positioning, especially in small environments. We use this power to deliver a report of the tags that were seen most recently by a given tag. So basically, each tag is listening for nearby tags on channel B, and then it says, okay, I am tag X, I have just seen tag Y on channel B, and this information is packed and sent on channel A, and received by the infrastructure. And in this case, the data collection pipelines become like this. Imagine that you have now 2 tags. This is what was happening here at 25C3. On channel B, the signal from this device is captured by this receiver, and this receiver sends out a message saying, I am 42, I just saw 13 at power 0. And then again, you get to the infrastructure, you get over UDP, and then you capture the data, okay? And this works. Actually, we tested this at our lab, and for example, this was a small room, maybe like this part, with 4 desks in it. And so here we were placing 2 tags on one desk and 3 tags on another desk, and you see that the structure is correctly represented. And here we had 2 tags on one desk, 2 tags on another desk, and 1 alone sitting on another desk, and so on. 4 on a desk and 1 alone, all 5 together. So we really tested this extensively. These were 5 tags in a line, and you see the topology is captured correctly. And so we validated this, and basically what we see is that with the hardware we had there and with the software we had there, we could assess very reliably face-to-face, proximity within 1 meter. Now, there is still the issue of the anisotropy, the fact that we want to be able to detect 2 persons facing each other with respect to 2 persons facing away from each other, but that's solved by physics, because the radio frequency at which these devices work, which is in the range of 2.4 gigahertz, is heavily absorbed by water, and your body is 70% water. And this means that when you wear as a badge, like many of you are wearing now, the device, you're only shining radiation at the lowest power level in a cone which is in front of you. You're not shining radiation to your back. And this basically solves the problem of detecting in a reliable way face-to-face interaction. Of course, if you wear them on your back, then you're messing up with our system. Please don't do that. So at 25C3, we moved one step further also the software. Really, along the lines of nothing to hide, we really wanted people to have their own monitoring station on their computer, on their web browser. And so thanks to the work of Wout and Vanderbreek, which works for us at ISI, we set up this nice Flash applet, which is embedded in the 25C3 OpenBeacon, OpenAMD pages. And the processing that's going on right now behind the doors is this one. Basically, you get the UDP packets from the readers. Those are aggregated by a system written in Python on top of Twisted, which basically capture at high frequency the UDP packets and pumps them in an aggregated form over a TCP pipe. And then the TCP pipe is processed by multiple post-processing systems. One of them is a backend engine which computes the graphs of proximity for a given room, for a given device, for a given set of stations, and so on. And then this backend is communicating again over TCP using AMF messages with the Flash client, and these two guys talk to each other basically. And so what you can do is show what people in social network analysis call an ego network, a network centered on yourself. And here, for example, we enter the code of a tag sitting on the OpenAMD OpenBeacon booth, 1100. And so this is the central tag. And here we are showing its neighbors and the neighbors of its neighbors. And the yellow contacts are contacts which are ongoing. They are current. They are happening now. While the bluish, greenish contacts are actually historical. So the fact that aesthetics and small caps are connected by this line means that they have spent time together, but they're not together right now, okay? While, for example, the fact that 1100, 1197 are connected by a yellow line means that they are together now. So this is the kind of information that's shown here. And then, as we have seen, you have also different views on the data. We really wanted people to have access to this kind of information in real time. And notice that this kind of information is a sort of a dream for people doing epidemiology. If you see how people do this kind of stuff in hospitals in recent years, they ask doctors, health workers to have notebooks with them and jot down who they have met during that day. And as you can imagine, collecting data this way is a mess, doesn't scale, and it actually impairs the possibility of this person of doing their work. So we do plan, for example, to deploy this infrastructure in a large hospital in Lyon very soon to get data which are relevant for the spreading of nosocomial diseases in hospitals. And then I show you what we did with this infrastructure, again, at our premises. This time we really don't care about positioning, so we had fewer antennas. And this is the kind of interface that our users had. This was not a web-based one. You got a better interface, but these guys only had basically a large screen at the conference, and on this large screen they could see, again, a sort of spatial grounding for the different locations in the building, and then a contact network. And as you see, this is not cliquish at all now. You can really resolve small groups of people. On tapping the device, people could recall on the screen statistics about themselves. And specifically, the system would tell them, you spent the most time with this guy, the second most time with this other guy, and so on. A sort of ranking of co-presence and contact. And as you see, you can easily resolve groups of 5, 3, 2 people, and so on. And just to show you what's going on in a very coarse way, here you have the number of persons in the 3 different rooms during a typical day of the conference. The red curve is the conference room, the green curve is the bar, and the blue one is the cafeteria. So the structure was basically a morning session, an afternoon session with coffee breaks in between, and this was lunch, basically. And we can, for example, zoom in on the coffee break because we know it's fun. And so we can, for example, go, let's see, to roughly here. Oops. Okay. And now you see that this looks very different. When people, I'm sorry, when people are sitting in the conference room, now you don't see this huge blob wobbling. You see just a few pairwise contacts, which are people actually turning towards each other to comment about the ongoing talk. Okay. So this really tells us that we are performing a much more accurate kind of slicing of real-world information. And now the coffee break starts, people get up, they start to talk to each other, and they move. And you see that in this case, you can really resolve small cliques, small separated, well-separated groups of people. So this new sort of firmware is actually capturing in a much more reliable way interaction which are socially relevant. And then you can see that at some point the coffee breaks ends. Unfortunately, it was a very good day, so people went out and to enjoy the sun, and so we lost a lot of signal during the coffee breaks. And here they go back. You still see a few people chatting with each other before the session begins. It's 11:09. Things slow down a bit, and you are only left after some time just with the pairwise interaction of people turning towards each other. So this is the kind of information that you can get. And, well, I'll stop here. But on a quantitative point of view, things look very different now. Because, for example, here you have the number of persons in the conference room. So this, when the number drops, this corresponds to coffee breaks. And now what you see is that the number of contacts that a person has ongoing is actually going up during the breaks. So when the situation is less crowded, which is really what you want. I mean, when you're sitting like this in a room, there is no ongoing social contact. We are all facing me, you're all facing the screen, you're not facing each other. So the average number of contacts that each of you has ongoing is actually low, maybe when you turn to your neighbor, okay? While as soon as this talk will be over and you will go outside or you will stand here and start chatting with each other, you will start having more contacts. So here, the system is really able to capture this. And you can go a little deeper and you can ask, okay, what is the number of groups of 2 people, 3 people, 4 people, the number of cliques that you have as a function of time? And again, you see that there is an interesting structure. Basically, except for groups of 2 people which are present at almost all time, the groups of 3 people, the blue lines, and the groups of 4 people are almost only present during the breaks. What's interesting is that the spiking of the groups of 2 people marks the end of the talks. So within a single session, you see this spike in pairs of people interacting marks the end of this popular talk, where people were really turning to each other and commenting and chatting. And there are several of these. So basically, by using this kind of more refined network observables, you're able to extract much more relevant information from the time series of this information. You see, you can basically tell where each talk begins and ends by using this info. And then before closing down, let me just point out that there are very interesting irregularities in human contact, which are rather surprising. They're not completely unexpected, but they're surprising if you consider that we are all free to do whatever we want in terms of movement, in terms of people that we go and talk to. But then if you measure by using this system the probability of observing a contact of a given duration, you ask the question, how many contacts lasting 2 minutes have happened? How many contacts lasting 10 minutes have happened? How many contacts lasting 1 hour have happened? And then what you see is that there is a very strong regularity. Here we are plotting the probability of observing, or the likelihood of observing, of a contact lasting delta t seconds as a function of that length on a log-log scale. Okay? On a log-log scale, a straight line is a power law behavior, so the functional form of this guy is delta t to the minus 2. You don't need to care about that, but it's really, I'm showing this just because it's striking that if you take 40 people, you observe them for a couple of hours, you get this kind of very strong statistical regularities, which are really important because the moment you have this kind of knowledge, you can disregard all the details, all the complexity of social interactions, and for example, create epidemiological models, model of information propagation, of information spreading, which are realistic because they have the right statistics of the contacts. You were able to experimentally extract quantitative information which is robust and can be used to inform modeling and the design of systems. So it's really striking that human dynamics is dysregular. And then, of course, you can play games. You can say, okay, imagine that at this conference there was a patient 0 with some very bad disease, and that's the red guy, and you can play back an infection dynamics. You can simulate a very simple epidemiological model on the real contact network. And so what we are doing here is pushing forward, in a sense, epidemiological modeling by providing it with data which are grounded on the real-life behavior of people. And then you have to plug in just a model for epidemic transmission on top of it. And so here you see basically that during the conference, not many people are infected. Most of them get infected, of course, during the breaks when you really spend time talking to each other. And then the last thing that I want to show you is the cumulative contact network. And this is the historical network that you can see in the view on your clients. And in this case, two nodes are connected if they have spent time together. And the strength of the connection depends on how much time they spend together. And what you can do in this case is do a sort of reverse engineering of social interactions, because at the end of the day, you're accumulating a lot of information about who spends time with, and by using background information, you can basically work back the identity of nodes for which you don't know the identity, just because you can somehow correlate this network with background information. And here, for example, you can see that this is an organizer, and at the end of the day, this node will be a hub in the network. The organizer needs to talk to a lot of people. And so basically, by using very simple network observable, you can point out social roles. And even, sometimes we had a couple of tags that were failing. We needed to replace them, but the person hadn't agreed to share their name. And it was very easy for us to just look at this graph and tell, oh, this must be this guy. And we were going to the guy, and he was surprised. You're not supposed to know who I am. And of course, we didn't know the association, but we knew the association of his neighbors, and that makes his privacy somehow compromised. So this is really an interesting observation in general, that your privacy is dependent on the care that your neighbors, that your social contacts take in managing their privacy. So it's not really your problem, it's a global problem, privacy, in terms of network. And here, for example, we had a little fun by plotting the cumulative contact network by profiling nodes. We had rich profiles with nationality, languages spoken, academic status, and so on. And so you can clearly see like kind of antisocial persons who never met with anybody. And you can clearly see the organizers, who are these two guys. You can see affinities and homophily related to language, related to co-publishing papers, related to co-presence at institutions, and so on. So there is really a lot to talk about, but I just want to give you an idea of what you can do once you get your hands on this kind of data. And this is, for example, a very rough preliminary snapshot of the cumulative contact network that we had here at 25C3. So I guess a few of you may find your nick or your ID on this graph. And here again, you see that there are some contacts which are strong, some group of people that are highly connected. There are people who act as bridges between different communities. And there are small groups of isolated people. There are a lot of pairs. And so on. So we plan to publish this data and some preliminary analysis on the website of our project. I will show you the URL at the end. Unfortunately, we didn't have time to prepare like in-depth analysis by the time this talk was supposed to be delivered, but we will provide it nevertheless after the conference on the website, either of the conference or our project. And so what about the future? In the future, we would like to have a couple of large-scale experiments. Here we had about 400 people. We would like to scale to 1,000, 1,500, because that's the right size for a lot of problems, especially for epidemiology. We have several medium-scale experiments planned where we want to explore instead different kind of connection, integration of background information. And it's important for us to really cover a variety of contexts. We want to cover conferences like this one, office behaviors, organizational dynamics, hospitals, as I mentioned, museums. In museums, this is very easy, and museums are very interested in having this information because they often ask this question on whether things or artifacts that they place in the environment shape the social interaction. I mean, what can I place in this environment in order to make people stay here, to make them more social in this area, or to make them go fast through this area, and so on. So scientifically, there are several goals. As I mentioned, we cover human dynamics, the longitudinal analysis, the analysis in time of the context networks of persons, epidemiology, organizational, understanding, for example, and mining informal networks. If you have an organization, you want to know who is the important guy. And that's not necessarily the guy who has the top in the organigram. I mean, maybe the important guy is some guy who has no special role in the formal structure of the company, of the organization, but still you need to recognize that role. And this kind of techniques, of course, with huge impacts for privacy, allow you to pinpoint who these persons are. And then integration with background knowledge is really something that I like. Especially I like this notion that was introduced at MIT of social serendipity. That is the idea that if you have access to the graph structure of contact, what you can do is look up information about these connections in online bodies of knowledge, and then basically feed this information back in real time to the people. So you can imagine a situation where I am spending a lot of time with Milos, but we are not connected on LinkedIn, and after a while we get on our mobile phone or in our email a message telling us, okay, you guys are spending time together, and if you want to connect to him on LinkedIn, on Facebook, click here. Okay, so this is, of course, this is really exploring a boundary, but I think that this blurring the offline and the online representation of the world is really one of the interesting things to come, and that's one of the things that we'd like to explore. So let me just acknowledge a lot of people who made possible this experiment here. This was very hard. It was really a fight uphill. And Milos made an extreme effort in order to make this happen. And so we are really glad to Milos, to Bit Manufacturer, to the organizer at 25T3, and to you all for making this happen. And if you're interested a bit more in the science, there is something you can read here. And more analysis and information will be posted to the blog of our project here on Sociopatterns. And thank you very much for your attention.
Okay, so let's do a hello, let's do a short summary of what we heard here. So maybe some of you are curious, how can we do such things? So how can be the CCC connected to such atrocities, to data mine people at their own conference while fighting for privacy? And he's doing it in a way to his own people like no one did ever before, and probably in the next few years no one will do. So what is the idea behind this? So what we wanted to show is that this is not the future what we are talking about. Obviously, there will some companies come out with products that will look very similar, because obviously the data that results from such approaches is very, very valuable. Obviously, you can see how important people are. You can pinpoint your efforts to the few important people. You don't have to talk to the suckers. You only have to tell the few persons. You know which people are, for example, less integrated. You can find weaknesses very easily. There will be probably, I think, the biggest market around this will probably on big trade shows where people will be systematically data mined. I expect a huge market there, so this will happen. Yeah? But this is the future. But the future is in fact already there. You people carry these mobile phones around which collect the very same data. So while you travel around, going to your daily jobs or travel with public transportations or traveling by car, meeting friends, this data is already there. And usually, you know it best, if data is there, people will use it. So please be aware what data, what tracks you leave in your environment. So mobile phones are a big issue. And most of you people additionally give information, like Shiro already mentioned, to others by, for example, publishing pictures on Flickr. So even if few of you people are trying to guard their privacy, this is not possible anymore, because if there are two persons around that give a shit about privacy, they will also inflict you. Your privacy will be removed. You will be on pictures on Flickr. Not pictures you took, but your friends took. So obviously we are looking at one of the biggest privacy threats in the future, and there's obviously a lot to explain. The motto of the Congress is nothing to hide. The problem is with nothing to hide is that people think, okay, it's public data. I walk from this room to this room, everyone can see it, it's public, why should I care? But in reality, if you systematically try to data mine this data, you get all the network, you remove all the trash, and you get the really valuable information. So you have to be careful about this. I think we have, how many time do we have left?
10 minutes.
Okay, so what I want to hear from you, what is your opinion about all this? And I'm very interested to your questions and to your thoughts about this. What do you think about this experiment? So, any questions?
Yeah, one of the outcomes of this is probably that you can, it would result in self-fulfilling prophecies, in the sense that if you have access to this kind of data, and you begin to realize, as you had mentioned, that the person who appears to be the big boss is not really the guy whom you should be focusing on, but you should be focusing on this guy who has got the most connections. So you could potentially just go and stand there facing him for a little while and become part of his clique according to this, so that later on if someone tries to look at these graphs, determines that you are actually also an important person as part of this.
Yeah, but
it's easy to game the system.
I think in the past we saw it in a different way happen. You have such systems. There is huge data mining going on, but exactly as you point out, the trick is not to change your environment by showing, okay, I measured you, here is how it looks like, but to make it hidden. So only few selected people know about the results, and these selected people are able to do whatever they do with the data. Yeah, but it's not public.
Yeah, but one of the issues is that I may not know who is doing the analysis, but I know that the analysis is being done. Mm-hmm. And I know that I am being observed, and I know that my actions are being reflected in some form or the other in a graph like this. And if I am able to determine in some fashion that this is how it's being done, I can game the system by simply determining who's the most popular guy in the room. And it's not the big man standing in the corner who you think everyone would go to, but it seems to be that small clerk over there who's handing out the food coupons. And you suddenly become, you raise your level of importance in some fashion or the other.
Yeah, so this is also one of our main drives, that we try to make the system now for you as open as possible. So we see exactly like Atul, which pointed this out, is what can I do? Obviously, I can introduce a lot of noise in the system. Like Chiro pointed out, I can veer the tag however it looks like. On my back, I can share my mobile phones with my friends, whatever. So obviously, you can poison this kind of data. And we also took, as a project, we obviously have a huge responsibility. We created, for proving that this can be done, one of the biggest technical tools to make it happen. So what did we do to make sure that it won't fall in the wrong hands, and if it will fall in the wrong hands, it will poison them? We made this hardware open hardware, so even we can't make money of this. If someone wants to take this hardware and we are simply too expensive, then he can build it on his own. So the profit margin is very low. So by introducing such tools into the open market and by providing this whole tool set a very low profit margin, a lot of companies say, does not make sense to compete in this market. There are already solutions around this. I may have fancy patents, but I don't expect too much profit margin with it. So I think there are possibilities to at least slow down this process a lot. And I think this is an interesting contribution to show the dynamics behind it, so people can use it in a better way. So in our experience, people don't complain as long as you give them the free choice to decide when do I want to be tracked. So obviously you are interested in, when I walk around the conference, who did I meet? What are their connections? Oh, he knows this guy. I can talk to him. Let him introduce me to another guy I'm interested in. This is a very interesting tool set, and I think because you find it interesting, you are willing to release this data. But as soon as you have privacy concerns, you have to have a possibility to shut this off. And this awareness, to train this awareness, when do I want to leave traces, and when is the border, okay, here stop, here I'm not willing to leave any more traces, and which traces are, for example, can be harmful. And this is what we want to achieve with this project, so to get this kind of data more attendance. Yeah. Next question.
Well, it's not directly a question, but what I found out, like you said, it's good to have the possibility of turning that things off. You can easily find out if someone's going out of this center across the street and whoops, he's gone. Or you can maybe find out if his business gone too long, or just having a short break or something like that. It's very impressive. One example from me, I walked into the toilet and some guys told me, your blinking was dead. And I told him, okay, that's the possibility to turn something off. I won't be tracked in here, because I don't want to know that anyone else knows that I'm on the toilet now.
Yeah, and because you see the immediate results here, so you started to get, I hopefully think, you get more aware that what actually happened. So, for example, huge companies, I don't want to tell you the names, are trying to do it in the hidden. So people won't get upset. Why should they? It's important data. You walk around in your store, you get the right advertisements. You don't get annoyed by the wrong catalogs sent to you. So it's very unobtrusive. It's customers never see what's behind this facade, and I think we achieve that you start to get aware what happens with this kind of data. Okay.
I have another question. Do you know how correct your data is? Are there false positives? And do you maybe have compared it to video surveillance of such a conference?
I don't think that you really can compare it to. I think you will get a complete different set of data, because obviously you are interested in some persons. For example, if someone is talking you're interested in, but you don't maybe want to talk to him personally, but you take part in the same group. But if you make a survey, you won't tell, oh, I'm part of this group of this cryptographer or whatsoever. You just are in his clique without basically telling it in a survey. But I think Chiro can say something to this.
I guess, can you hear me? Yeah, okay. Validating the data is one of the big issues indeed, because that's why we started, for example, in our experiments with very small groups, because we wanted to be able to relate what the system told us about the structure, the topology of the interaction with what we were able to see with our eyes. So we really spend a lot of time, entire days, having people standing in rooms in group of 3 or 4, and we were telling them, okay, now you move to that group, and now you come back. And besides having these guys very upset at us, we really were able to validate that with the settings and the parameters we had for our experiments back in Italy, we were able to detect very reliably face-to-face interactions. Of course, you do have false positives and you do have false negatives. That's part of the game. But the important thing is that you know that the noise level is low and that you know that the error is controllable. You know the statistics of the error. The other thing is that even in cases when and this is the worrisome thing, it's very easy to detect when people are trying to mess with you, because basically if you put the tag on your back, suddenly the statistics of your contact times, they're all wrong. And so by just mining the network in clever ways, so you can tell, okay, this guy is playing tricks, and you just remove the nodes. So it's very easy to use a lot of mathematics from complex network theory to clean up the data and to somehow remove noise that is deliberately introduced in the system. The other thing which I would like to mention is that even though we are all scared by the big brother, it's actually even more scary how people themselves start using these technologies very, very happily. We had this screen, and what we saw after a couple of days of people playing around, when they had become confident and aware of this possibility, is that, for example, if an important guy, if a very well-known scientist entered together with somebody, you would see a bunch of people running to the screen and looking up the connection to see who the other guy was. So it's really scary how easily people adopt these things, how much they start using them. And so that's another issue which we really need to address, I mean, in how we expose this information. And again, there is an issue of responsibility in that information is there, and it's there for use for everybody, and it's very important that, in a sense, there are provocations in order to let people become aware of the issues before they get used to the technology and to what they can do with the technology, while it still feels new.
Just to give you a short reality check, so obviously you think, oh, we have here the 25C3, we have here a lot of bright young people which are very aware of privacy rights. They will protect their privacy very well. They are aware what can happen to their valuable data. But from my experience, Ciro can correct me, this time we took it to a different new level. Unlucky Aesthetics is not here. He did amazing work with some other people together on the Hope Conference in New York, and he was willing to come here and to work very hard day and night without sleep to make this happen on 25C3. We introduced a lot of additional data mining possibilities. For example, you were able at an early point to sign up for talks you want to attend, which obviously is interesting. I can correlate it with what you want to attend, what you think that people want to see you attending, and what you're personally interested in. For example, if you have a talk about privacy and you leave in half the time, then obviously it tells things about you. There were a lot of possibilities where people left data. You could, for example, ping friends that were suggested by you to the system, from the system, based on the talks they signed up, based on the rooms they were in, based on the interests they registered on our website. You could enter handle, you could enter your age, you could enter your email address, your interest, everything. And you would expect that people come here bashing to us and say, oh, why do you collect this data? No single person asked me what will happen with this data. We can tomorrow put it into a newspaper and say, here is the data, email addresses, private interests, people they met, websites they have. No one really cared at the 25C3, so think about it. Yeah, and they trust Google, they trust Microsoft. It's good that you trust. It's good in this times that people still have trust. Thank you a lot. Okay, there is one question. Okay. Last question.
Not a question as such. Just one more thought that came to my mind, because when we were interviewing a few candidates for our own company, there was this talk that there was a company that actually profiles a candidate based on what they do is basically Google you, then they do your, they check your Facebook, your Orkut and your LinkedIn, and then basically they give you a profile of your character. So that was real scary stuff. We actually banned that kind of companies approaching us in our company, but there are companies like that, and that is again against the privacy. So this might be something related to that too. Yep. Just a thought on that, nothing much of. Thank you.
Thank you for the info. Okay, so if one has further questions, meet us at our booth and we will happily answer your questions and share your privacy concerns.